for up to 8 hours now.
don't 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 get greedy there, Steven.
Anybody up for a marathon today? This would be great. OpenWorm Hackathon. Actually, that would be fun, a virtual hackathon. Anyway, okay, so thanks, everybody. Looks like we may still have a few more stragglers coming in. I'm not sure. But so there are just a couple of organizational updates. We are having a journal club this Friday for the DevoWorm sub-project. And so you'll be hearing from the folks there that are working on the challenge of building up a computational representation of, or a computational model of the development of the worm from what we already know about all the cell lineages of the worm. And so this so far has been somewhat of a distinct effort, but not for lack of excitement. And so they're going to hear a little bit about the approach that's being taken over there. And I hope that we can engage with those folks even more and think about sort of common points. One intersection point that's already been built is that PyOpenWorm, the unified data library intended of the project, has lineage information being built into it, so it can at least be a common point for that kind of data. In addition to all the other stuff that it's got, so cells actually know about lineage. And so that is at least one way in which it's integrated, but obviously we want to keep thinking about more ways. So, and then we put out a call, I think last week, for folks to help with a math thesis, and it looked like that was going to get scheduled for 2 weeks ago, Friday, and then it didn't. Just due to some scheduling problems, but we're still working on getting that scheduled to come up here for a while. And the idea behind this is that there's some topics in sort of complexity science that could be relevant to understanding the nervous system of the worm and also its cells and things like that. And this would speak directly to that. So. Anyway, we'll see when that gets scheduled, but stay tuned for that as well. So those are the main things. I actually have some updates with regards to code, but I will wait my turn in the queue so that it does not take any more prominence over other stuff. But I will speak a little bit about that a little bit later. So let's go ahead and go through some individual updates. It looks like Michael has some movement validation, nicely structured, news, so take it away, Michael.
Okay, so I put my individual update in the form of an update for the whole movement validation team here. So our code progress chart remains unchanged right now. I think I've linked to that a few times the last couple of meetings. We're basically attacking the port of this Schaefer Lab code on multiple fronts, with a couple of new people trying to attack the machine vision piece. I'm looking at the statistics, and Balash is actually looking to try to add his motifs code from MATLAB into the repository also as an additional feature. So that'll be a nice test of our extensibility, our ability to add new features and calculate more features from the existing base set that we inherited from the original Schaefer Lab code. And Jim's sort of looking at the big picture and assisting in various places of the port. He's just had a big funding application that he was working on at work, so I spoke with him yesterday, and he's now relaxing on vacation for a couple of days to take a rest from that. But once that's over, I think he's going to continue to work on things. He's also working quite a bit on this MATLAB standard library of his, which has sort of ancillary benefits to the effort here. Anyway, so that's a separate project that he's working on also. But yeah, we're definitely getting some new members thrown at us from the general queue of people that are looking to start working on OpenWorm stuff. So we have Theodore Brown, who is interested in computer vision, and another person called Ryan Brackney. He's also interested in working on things. So basically, when they come and ask, if they can contribute in some way, what I like to do is basically see if they can at least install the repository and get it running. They can get things working on their computer, and if they can get to that point, it's almost like just installing the tool chain itself is like 50% of the effort. If you can get to that point, then they might continue to remain interested and do more. Aaron Lang, who unfortunately has had to step away for a semester, he got to that point and was looking pretty closely at the track-a-worm code, which is a different tracking system than the worm tracker that we're porting, and so he had some valuable insights there. But unfortunately, he's had to step away. So hopefully, these new guys can step up and continue the effort. But yeah, we're basically attacking it from all sides, and hopefully soon we'll have some major progress here.
All right, awesome, very cool. So lots of things going on. What is the main thing, or question for you, so what is like the main thing that runs now when you go to the code? Like, what are things that people like jump in and they want to like play around with examples? Like, what actually runs?
Yeah, so there's two examples that currently run in the code base. I can just send everybody a link to that. So in the movement validation repository, it's set up as a package that you can import. So you can do import movement underscore validation and then run various things within it. And we have two examples in the examples directory that will do just that. They'll import movement validation and do some stuff. So one of them is plot example, which will take an example feature file and use movement validation, the package, to sort of encapsulate various attributes of that HDF5 file that stores the features and then render it in various ways. So there's that example. That's what it can do right now. And the other big one is validate features, which is kind of a unit test, really, but it also just sort of demonstrates the feature generation capability. So in this case, again, here let me just send everybody a link to this code.
Yeah, that'd be cool.
Here. So if you click on that, you can see. So it's pretty short. Basically, it just imports movement validation and then imports not a feature file this time, but instead a normalized worm file, which is basically just describing the contour to keep it simple. And then from that, we actually generate the features like amplitude, velocity, things like that. And then this validate features example, as you can imagine from the name, it actually attempts to validate that the features that we've calculated line up with the features that the original MATLAB code calculated. So those are the two things that we have in the example directory right now.
Okay, cool. So examples, validate features, plot example.
Yeah, so if you're looking to get this to run on your computer, that's definitely the place to go. So you try you clone the repository and then make sure you have the right third-party packages installed, and if you can run these two examples, then you're 50% of the way to being able to contribute.
Okay, awesome, very good. So I'll see how things keep going there.
Yeah,
with that stuff. That's excellent. Okay, let's go on then. Thank you for that. To me, So I've been working on the PyOpenWorm Alpha. Let me share that. Share my screen again, and let's just navigate over to it. I feel like doing a little bit more show and tell today. Anyway, we probably have a little bit more time. I don't see as many folks here today. So I've been working on, there's several different branches. The main one that folks have been working on is Alpha 0.5, And I've opened up a sort of sub branch to that called Alpha 0.5 Slarson. And so let's see. So yeah, so there's been progress that's been made on Alpha 0.5, but I've been sort of doing in the last few weeks quite a bit of cleanup as well. Basically, what Alpha 0.5 does, it actually is a rather significant update to the master branch, and it basically puts sort of a whole database behind what we had. Oops, I went too far. Alpha 0.5 puts a whole database behind what we had using something called Zodbee, the Zodbee database, which is a pure Python database that does allow for graph structures to be put into it. And the idea is that this database is the sort of the unified place for data in the project, and its intention is to replace the spreadsheets and other forms of data and be kind of the latest version place. It allows for individual facts to be sourced and referenced to individual papers, so evidence can be provided for each piece. But I've been hesitant to turn over the chain to master because it has been a little bit more complicated in the way that it's been programmed, and so it does heavily use generators, which if you're not a Python aficionado or I don't know that experience with Python, you may not be super experienced with. So and this is sort of some of the choices that were made by our Google Summer of Code programmer. So I've been working with him and going back and forth with a lot of issues and trying to figure out how we can make sure that it is simplified and this is not more complicated and that it is as correct as the other database was. So we've been having a back and forth. But when it is ready, which I hope will be in the next week or so we can sort of turn this over, the idea is that folks won't really need to worry about its implementation. There still should be able to make simple calls to basically just think about querying this library the way that you'd ask questions about the anatomy. So if you want to get information about a particular neuron, you can get its name, you can get its receptors, you can find out what type it is, you can find out how many chemical synapses go in and out of it, and all that, not really worrying too much about how it's implemented. But you can do eventually other fancier things like once you find out sort of what the receptors are, you can ask, well, how do you know that, and get a reference to a paper. So this is a digital object identifier which references an individual paper. So that's actually very nice. And this is both a read and a write library. So also with Python code, you can actually add facts into the database, and they will be preserved. And then if you update the library back into, so if you sort of fork and then do a pull request, your changes to the database will come along with with your changes there, so that we can also sort of collaboratively update and edit and make fixes and changes to that.
So,
and yeah.
Where is just if I'm making any assumption which is not correct, just tell me. But so I'm getting that now there is a database, okay?
Yeah.
And my question would be, where is that DB? Because I heard a name that I didn't hear before about some Python technology. But in terms of actually hosting it, where is it? Is it just GitHub? Is it?
Yeah, it's in GitHub. It's not a hosted thing that lives somewhere else. It is within the library. So that's kind of the idea here, is that the data is actually versioned in with the library.
So is it that folder OpenWorm data at 0437? Is it that?
Yeah, at the moment in this alpha, yes. So that's where it is right now. We're sort of having a conversation about if this is the best implementation of it, because it is implemented as a sub repository right now. But yeah, it's in here. That's right.
Okay, so whenever you play with the Python API, there is like somehow code that pushes to GitHub, right? When, let's say, you add an evidence, then and you decide to save, that ends up being some kind of push to GitHub by that API that you're using?
Not automatically. So the way it works is that folks make local changes, and they have to elect to basically do a commit, a git commit, and then a pull request. And then, as with any code, it's rather than being in binary, it gets you have the option to do an export, basically. And so we're using basically a text exchange form that the database reads in order to collect the changes, so that it'll actually create a diff, a text diff, to actually see what data has changed, and then maintainers of the library can decide to what extent they want to incorporate those changes or not to the data.
Oh, okay, okay. So, and what was the name again of the Python DB?
Python DB is called Zodby.
Zodby.
Yeah, here I'll sort of, yeah. So that's kind of what's
database for Python.
Yeah, and it's being used as a backend for something called RDF-lib, which handles the graph aspects of it. So you can have a look at that.
Okay, cool. Thanks.
All right, sure.
Question, Stephen.
Yes.
This is very nice. Is there? I remember that this, but then I kind of got disconnected from this a little bit. At the beginning, I was looking into it, but the question that I have now, it might be a stupid one, but maybe somebody else is wondering into. Does this somehow have a way to sync up with the NeuML stuff? So can you export or import? Or so just to understand, like somebody starts working with this, how do we translate that into? And I'm sure, you know, I just don't know the answer to that.
Right. So this is it is part of the API to be able to generate NeuML files, but it is not fully implemented at the moment.
Okay.
So, but that is the idea and the plan, and there is some connection that has been sort of sketched out in the C302 repository, in that there has been some modifications to the script that will use PyOpenWorm. I believe that was to the current master, though. I don't think that's been sort of rebuilt yet in the context of this new alpha, because there's sort of, as it got kind of more, as the code base kind of expanded, there's a lot more like checking that needs to be done to make sure that stuff is still, you know, accurate and correct and all that. But I think that what we were really doing here was laying a foundation that would allow a lot more of those sorts of things to happen, and I think we kind of got into laying that foundation quite a bit more here, and expanding what we could do through sort of graph queries that you know, that sort of held up the process of working directly with the NeuML stuff. But that is now something that we can go back to and address in subsequent versions of this. So yeah.
Yeah. I just add to that. I mean, for most of the NeuML stuff that I've developed, whether it's importing into NeuroConstruct or generating something like C302, that's using some of these spreadsheets that have been around for a year or two, pulling the information out of that and either putting it into NeuML or checking against the contents of the spreadsheet. Now, C302 and NeuroConstruct still use that spreadsheet, but once there is a version of PyOpenWorm that Stephen's happy with to put into master, then I'll definitely replace all of that with just calling the appropriate functions in C302 or in PyOpenWorm, and then the two of them will be happily compatible. And right. I mean, I'm not sure where I mean, I see that there's some information and getting information about morphologies from PyOpenWorm. I'm not sure where exactly that has come from, but definitely we need tests between the different versions, between the save NeuML version and PyOpenWorm, to make sure that all that information is consistent. And ideally, once there's information on where all that information has come from, then we can stick that into NeuML and so on. But yeah, there's definitely plans. I mean, we know generally where things should fit and how they should work together. But it's just a case of first getting a stable PyOpenWorm and then integrating it with everything else.
Exactly. So, and as an example of a project that I've been helping a volunteer to work through over the last few weeks, so there's a gentleman named Ari Richmond who has been both playing with the C302 side and with the PyOpenWorm side. He came in with an interest of looking at social behavior in C. elegans, and so we were looking through a Corey Bargman paper that looked at a specific circuit, a sort of hub and spoke circuit that centers around the neuron RMG. And he just basically wanted to, play around with some neural networks. So I thought, on the one hand, he could look at what's in PyOpenWorm and write a script to basically pull out what we know about RMG and its nearest neighbors and the connections that are in that database and see if they compare to what's in the paper, the step one. So that got him engaged in using that. And on the C302 side, because of the nice convenience calls that Porg has put in there, you can sort of select any group of neurons that you like and start plotting them, right, with a very simple network. So then we also said, okay, let's look at those, 6 or 7 neurons, and let's run C302 with just those, and let's see what sort of dynamics we get, and we can at least see like if we get sort of excitation and inhibition more or less like we might expect it to. And so a lot of this is really kind of both on the one hand, getting somebody who's not as familiar with the neuroscience and the biology introduced to some of the basic ideas of computational neuroscience and the neuroinformatics side, but it's also providing a user who will sort of potentially run into any of the sort of infrastructure challenges or installation challenges of setting that stuff up. So it's been kind of a nice interaction there to kind of make sure that our stuff is actually usable and to point out any bugs or problems with our data or anything like that. And so hopefully he can help to lead the way in that kind of project as well as we go. Sort of now we're kind of eating our own dog food, so we get people to sort of collectively with us eat our own dog food when it comes to the things that we're putting out there and make sure that they're actually, the high quality resources that we want to produce. So hopefully he can drop by in one of these meetings in the future and kind of present on some of his progress. Okay, so then the other thing, so Rainer Lucas isn't here today, but we've also been working with him a bit, and I got a chance to sit down with Porg actually, I guess last week, when I was passing through in London, and we were looking more deeply at the muscle model, and so we kind of drilled into going back and forth with Rainer. We've been plotting IV curves of the individual channels, and we identified a place where the calcium channel for the muscle is actually missing in an activation gate, and with Porg it sort of raised some other questions about calcium management in the muscle model and that kind of stuff. And so I hope I didn't put too much extra work on Porg's plate for that. But we've started. We've got a start on that within the muscle model, a fork of the muscle model project, just kind of looking at how we might extend that channel. And I'm sure it raises some other complications, but at least we've got some progress on that. So that's also happened in the last couple weeks, and I think it's kind of good. Okay, so those are the 3 things for me: PyOpenWorm, working with Ari, and the sort of the calcium stuff with Lucas. So very good. Let's move on to Giovanni.
Hello. So my update will be brief because last 2 weeks I was on holiday. Went to Ireland and then back on Sardinia. The agenda disappeared.
Sorry, it was my editing wrong key.
My script was taken away from me.
The NSA is hacking OpenWorm and getting our stuff.
Yeah, so didn't do much, but I got back in the last week and checked back in on the stuff that I was doing before I went. So mainly like Kickstarter, Aftermath. So far, and people who are here, I'd like to hear from you as well. Physical rewards, nobody has complained that they didn't receive them. T-shirts and posters. So, Roderick, Michael, anything? I know that, Michael, I know that your mama was waiting for a T-shirt as well. Did she get it?
Yes, actually, she did. I asked her if I could post it to Twitter, and she said she was baffled by that idea and definitely said no. Why on earth would anyone do that? But yeah, she got it. She sent me a picture of herself.
That's great. So
I was having a meeting with Boris earlier and Adrian, and I noticed there is now an OpenWorm poster actually hanging in the lab next to where Porg is sitting.
Oh yeah, I saw that. I saw that in person. Also, Rick Gherkin with the Journal Club the other week had his poster up behind him when he was doing the Journal Club.
Yeah, that was subtle, but he had that there. That's right. Yeah.
That's very cool. Yeah, so I mean that stuff is out, and there's some surplus that as soon as we see each other we can loot. But pretty much like we got some more because there's a bunch of backers who never replied to the surveys. So just in case somebody wakes up months later and say, "Oh, I didn't fill out the survey," so we have some stock, and as soon as we see each other before the end of the year, we'll bring it, and people who have received anything that we can just loot that stuff. Also stickers and stuff like that. So that stuff is going well. And then I don't want to talk about this. I don't want to steal Steven's thunder about the OpenWorm Academy, but that's Kickstarter stuff as well. Steven, do you want to say a few words about that?
Yes, I'm presenting lecture 5 in 2 hours. We've also launched to the spectators. Lecture 1 and Lecture 2 should be coming today, and then we have also been working out the guest lectures for Lecture 7, which will be in 2 weeks, and I've been doing some recruitment amongst some of you. So thanks, Porg, for replying, and yeah, it seems to be moving along quite well. So I will also at some point share with you all here the contents of the Spectator stuff, those folks who are sort of core team folks, but just getting it off the ground here in the last few weeks. So basically the way it's working is that the Spectator access is lagging by about 4 lectures, so that there's time to go back and you know, up the quality and sort of do some edits on the YouTube videos. Some of the stuff that happens on the live side are sort of just specific to the live interactions and sort of not that useful for somebody watching, and so sometimes it could be like 7 minutes of really irrelevant stuff for somebody who just wants to get out the content. So so we've been kind of shortening and truncating some of that stuff. But that's going well, and of course always thinking about what to do with the next version of this as we start to get this content in the bank, and to what extent, you know, folks have been suggesting, you know, should you make it a Coursera course, and other folks have been suggesting, you know, maybe there's some way to put it up but have like a donation box and to kind of continue supporting the project. And so,
Stephen, can I just interrupt and ask where right now is the content? I just put a link here in the group chat, and I see there's OW Academy. And there's a lecture 2, but that contains the readings. I just wonder if maybe there's another place somewhere that I'm just missing where the content is, or I guess you're saying that it will eventually be made available.
Yeah, so because of the sort of the exclusivity of giving it to only some backers, we haven't posted the content publicly.
Sure.
And so basically the content is spread out amongst a few different things, and it's a little bit different for the live and for the spectators. But for the spectators, there's we've made like a Google Sites website, a very simple website that just has basically every lecture as a page and the course overview and that sort of stuff. And then we're linking, and then the actual the lecture itself is on YouTube in a sort of like a private YouTube videos that are then shared with specific Google accounts.
Okay.
So far, actually, and also you can share it with like circles. So we made up a circle of all the spectators so far. And then when you're in the Google, so the Google site is permissioned, and so specific users have access to that. And so again, logging in, and then the same thing with YouTube. And so between those two mechanisms, and then I think the site also has some files. So there's PDFs that are associated with readings that are given for the material and the content. So,
what's the total number of spectators that you're getting right now, or participants, I should say?
I think the spectator list is on the order of 40. It's a little unclear who's actually using the content. I haven't actually checked the view counts on the first video yet. But I think that's certainly the number that we sent out to. And then there's about 6 or 7 continued participants on the live side.
I think it's one of those things that it'll have legs in syndication. It'll be like the original series, right? Like it might not get watched in original broadcast, but it'll be a legendary thing in years to come. So
maybe. Well, I don't know. So it's kind of, as I'm going through it, I'm also seeing like room to improve the content. So it might not hurt from like a second giving of it that kind of polishes up all the goes into more depth later. But yeah. So.
Yep. I think now that everything is in place, we could add the circle of us, like OpenWorm, and maybe people who haven't backed but who are contributing to OpenWorm and stuff like that. We need to talk about that kind of stuff, but so that this is available internally, right? Because the exclusivity is a good point. Like we're open and everything, and somebody might be saying, "Oh, you're doing this academy, but it's not open to everybody." But, everything is open, but this was one of the Kickstarter rewards, and that's why it needs to be exclusive to people who pledged for it.
Yeah, for now.
But for now. But I don't think I think it should be. I mean, we as OpenWorm members, we should have access to that for reference. Okay, so I'll keep going. And then, so the Academy, what else in the Kickstarter stuff? Thanks, Michael, for correcting my capitalization.
Sorry, I'm neurotic.
I'm the same. I don't know why this time I didn't do it. So Worm Sim development, I'll leave that. That's integrated with Gepetto development, but everything's going well. I'll leave that to Matteo's update. And we discussed the Worm Sim development a bit more on Gepetto meetings on every second Monday. And everybody is free to join there. They've not been streamed live, which is something we might look into, but everybody's invited to join to know more about that stuff. There's a number of other Kickstarter relevant activities that are going on in the background, such as reorganizing the second open world retreat. I don't want to announce anything yet because we're still working on details, and a number of people, such as confirming dates and things like that, but we're very close, and thanks for helping with that, for booking the rooms and everything, but there's going to be news soon to the larger circles. And okay, so other than that, I jumped back into what I was doing with Gepetto development, and where I left working on proof of concept and design for dynamically loading front-end components for the Gepetto UI. And when I was back, I saw that there was another proposal from Matt, who's also an OpenWorm contributor working on Gepetto stuff. Working on Worm Sim, and so pretty much I proposed. I was thinking about an on-the-fly approach for adding components from the client side. He kind of took the other route of proposing a server-side approach, kind of build time customization of the front end. There's no reason why we can't do both. But at the moment, I'm basically catching up, trying to review what Matt proposed, and there's a discussion on GitHub going on at the moment for anybody who's interested, and I'm just gonna post the link to that thread in the chat. So that's going on right now. But, so I'm pretty much catching up this week and that's the thread that I was talking about. Yeah, so that's pretty much everything from me, and um, I'm looking to get involved in some other development task this week and keep going with the Kickstarter long tail of things to do. Um, I think most of the things are underway, but another thing that I want to mention about the Kickstarter is we had this Adopt a Neuron initiative, and that's happening right now. We are preparing certificates for people who adopted a neuron to send out, and we're going to need some help in terms of understanding where because for people who adopt a neuron, we're going to kind of add metadata to the neuron themselves in our C302 NeuroML stuff, right? So, Podrick, I will be looking for...
OpenWorm.
Yeah, and OpenWorm. They're looking for help from you in terms of understanding what's the best way of doing that. Tagging the neurons with backers' names and things like that. So I'll send you an email probably this week. But the certificates are being prepared. The list of the adopted neuron has been drafted. So we resolved kind of conflicts where people pick the same neuron. We did it based on who backed the Kickstarter first, and it was quite a bit of work. So that stuff is going on, and we're making progress. I'm kind of hoping by next week to have everything sent out and certificates sent out, and then tag the neurons. And the nice thing is that when we load C302 in Gepetto and in the worm sim, we will have, with the NeuroML widget, a way to display the backers' names as part of the metadata of the electrophysiology of the worm. So that's going to be nice. Okay, so
Yep.
I think that's everything for me.
Yeah, I mean, that can be done in the NeuroML in the short term, but also probably can be done in PyOpenWorm, so that if you have neuron equals n, or n equals neuron, then n.owner, and you get the name of the owner.
Yeah, definitely. Good stuff. Okay.
All right, groovy. Looks like we have an update from the Gepetto Horde by Matteo.
Am I? No, I'm not. Yes, I was trying to follow the example set by Michael today, since this captures a lot better the kind of things that are going on from a high-level perspective. So I tried to list, and hopefully I haven't forgot anyone, that is contributing to Gepetto. So the first thing links just to the website, the second thing links to the waffle board, and the third thing links to the last meeting agenda, where there's more details about the stuff that is going on. So update for myself. Well, I'm spending a lot of time just like having individual meetings with the different people that are contributing, trying to put all the efforts on clock so that things happen when they should happen at the same time, so that we can move forward as best as we can. Spring 34 started, and you can see in the board what things are part of it, but I also summarized them in the individual updates. So in terms of code, I was working on fixing loading of a plain LEMS model, which is something that got broke and now is working again. And I just closed that issue yesterday, and then I started working on loading of a recording, which is like the follow-up from what Johannes did in terms of creating the recording. I hit an issue yesterday trying to get a netcdf, which is the library that we are using Java side to load the HDF5 files. And so I had unit tests. I was loading the HDF5 files from just the local resources of the bundle, and that works fine. the API says there's an open method, so you can pass any URL to that. So the API says that you can just pass anything, even if it is remote. But when I did that, it didn't work, and it's saying file not found, although the URL is valid, and I don't see why it shouldn't work. So that's something that I will need to spend more time. Probably I will end up having to mail them or put into some forum request of help, because that's something that they explicitly say it should work, but in fact it doesn't. And which is going to be a roadblock in terms of loading an HTML5 file from Gepetto, because that's the best library I could find to interface with HTML5 files at the moment. There's another option of wrapping the official library, but that has native libraries, and it's going to be a bit time consuming, although it would be the ideal option. So as part of this sprint, I will also release 0.1.7, which will have quite a few things. Now, I won't go through what Giovanni already said, but Jesus is now working on adding support for connections between the different Gepetto entities, which will give us, for instance, the ability of loading a NeurML network and navigating that network. So we will know what neurons are connected to what, which is going to give us some nice samples. Like we will end up having, by the time this is finished, we will be able to load things like the OpenWorm multi-compartment network, for instance, in Gepetto on top of C302, which we are already loading. But we will also see how these things are connected. At the moment, the C302 in Gepetto looks like a ball. Like there is all these different cells, but you cannot say what the pattern of the different connections is. So this is something that will be added as part of this work that Jesus started now. So Adrian has a pull request for a lot of stuff, the events framework, which allows the different widgets to contribute actions to the Gepetto framework, which means, for instance, that you contribute something like a plotting widget, and the plotting widget can say, hey, every time the framework is showing what kind of things you can do with a variable, I would like to contribute one action. And that action is that I can plot variables. So that you are, for instance, in one widget, you right-click on the variable and you say, okay, plot this. And you can say that plot this because there is a plotting widget installed, and because there is this nice events framework that Adrian contributed. And the pull request also includes the widgets to visualize trees. One widget uses .gui, and the other widget uses d3.js. So we'll start experimenting with these, and this combined with the work that Jesus has already done in terms of creating both server-side and client-side, all the specific objects to represent the variables, the expressions, the parameters, will enable Gepetto to show what model is loaded. At the moment, you load the Hodgkin-Ackley cell, you see it spiking, but you want to know what the model is, you really have to manually open the NeurML file and see it there, while we're moving towards the direction where that information will be exposed through Gepetto. Matt is working on splitting the components and factoring out things that are coded in Gepetto, so that we can, a prerequisite for building the worm sim in a way which is not just a fork of Gepetto, but rather a customization of Gepetto. And also started working on the logging system for the worm sim, doing explorations in terms of what different possibilities we have. Boris is working on, and actually had a meeting with him, brief meeting with him today, is working on linking how variables are simulated with the changes in the visual aspect. And today he just showed me this sample where he's making the cell that we have in the first sample rotate as a result of the change of the membrane potential. Obviously, this is just a silly thing to do, but like it will enable us, for instance, to connect the equations for something like a pendulum with actually having a 3D object that oscillates in space, which is the next thing that is, now that the infrastructure is starting to be there, is the next thing that it will work on. So Johannes, who finished his Google Summer of Code, he's going to do some more polishing of the code and adding some more documentation. Sergey is also working on documentation, and Martin is working on extracting the skeleton. And this is basically, he already completed the work to extract the mesh out of the PCI SPH simulation, out of cybernetic, and he has also now extracted the skeleton. Now the next thing, but is now is going to be away for a couple of weeks as he's getting married. But
Matteo, is that something you can show?
Yes, it is something I can show. Wait, I just need to find the link, okay? Do I have it? I think this is
something kind of visual and kind of cool beyond the description.
Yeah.
So.
Yeah. Okay. Wait. Let me. I definitely can show you. Just give me a second.
Cool.
Let's see. Okay, so this is the result of the mesh extracted from cybernetic, loaded in Gepetto. So this is the result of the work that Martin did. Okay.
Oh.
And I don't know, can you see the screen?
Yeah.
So as you'll see, there's no texture, and in this one, in this specific one, there were not even yet the normals for the different polygons. But now he has added that, and he's also added the skeleton. So that means that we are one step removed from basically processing all the steps in the simulation, calculating the rotation of each one of the joints of the skeleton for this, and then we should see that animation wiggling. Obviously, I'm making it simple, but it's actually a bit of background on Martin. I don't know how much people know, but is basically doing a postdoc, and his whole work for his PhD and master has been in terms of doing processing of cloud point representation to extract things like the mesh and the simulation. So it's like this is another like a sub project where OpenWorm is kind of pushing the boundaries of research in different areas, because this is actually it's not like standard code, it's not standard algorithms, it's a research problem, and Martin is working on it to solve it, and it showing great results so far. So
was there a part of this though where you could look at the skeleton in the animation?
Yes, not in Gepetto though, because we do not show skeletons in Gepetto. Let me see if that's something that I can easily bring up as well.
So what I like about this is that we're kind of getting some of the worm browser functionality now, as you can see, actually showing the full shape of the worm into Gepetto, which is good, because worm browser was pretty monolithic and pretty hard to kind of update and hack things into, and obviously now we have this in our environment here. But this next thing I think that Matteo can show is also going to give you kind of a sense of the next exciting bit that is going to come in there.
Okay, this is Blender, and every time, so apologies if I'll be very slow, but first of all, I don't have a mouse, and using Blender with a touchpad, it's like the worst thing that you could try to do in your life. And the other thing is that I'm not a Blender expert in any way, so every time I have to relearn how to use it. But if I do this, you should be able to see the skeleton of the worm, so I can make the mesh transparent, and now you see that it's not basically now it has normals, it's reflecting light, etc., etc. And in terms of the skeleton, there is like there's a shortcut to be able to I already forgot what that is. Post tool, wait, no, I think I found it. So if I do this, aha. So now obviously I'm doing silly things, but
there you go.
This is what happens when a worm has a skeleton. So
Pretty nice. Pretty nice.
And now we'll see one thing for how these things work, and I myself learning this as we go along. It's not that I am a 3D guy in any way. I'm trying to just learn as we go. But one thing that you learn, speaking with people with like Martin, that has a lot of background in this stuff, is how this thing actually works. So in order to have what we have just seen, which is the mesh rotating, for instance, as a result of a rotation of a bone, you need what are called the skinning weights. So if in an issue or something like that, from Martin, you see the phrase skinning weight, basically the weights describe how a rotation, how a transformation, not just a rotation, how a transformation of the bone of the skeleton influence each one of the vertices of the mesh. Now we have a first set of simple weights that he used with some kind of basic algorithms, and we'll have to evaluate if the skinning weights that he has are good to make the worm wiggling when he will apply the appropriate transformations to each one of the segments. And but it might be the case that after we look at this, then the weights won't be good enough. Then we will have to look at like some improved algorithms and methods to calculate more advanced weights, etc., etc. So this is part of the research problem that Martin is solving, but we have already made great progress, and that's where that is.
And do you also just want to remind folks like why we're doing this when we already have sort of SPH, and because I think this is actually now your strategy that is bearing fruit.
So we're doing this because Cybernetic has 200,000 particles, and streaming 200,000 particles for each time step, where a time step is 5 microseconds. If you want to simulate like even just something like half a second of the worm, would require bandwidth that none of us has. And so the strategy was to move away from streaming the particle strategy and having a post-processing of the cybernetic simulation to extract the mesh that would be much more lightweight. And instead of streaming position for each one of the particles at every time step, we will only be streaming the transformation matrix, which is going to be a 3x3 for each one of the joints. So we have 22 joints in the current model, and basically it's going to be a matter of streaming 9 float point numbers per each one of the segments. So 9 by 22, okay, which is roughly, let's say, upper bound 250 floating point number. That means that every time step becomes 250 single digits numbers, as opposed to being 200,000 by 3 single point numbers. So that's why we're doing this. And the mesh, the first one that I shown that had no normals and had no skeleton was 200 kilobytes. So it was very lightweight with the normals and the skeleton and the skinning weight. So it should roughly speaking, should be like the kind of final size, more or less, we are talking about 2 megabytes. So it's still something that, and it's once off. So we are already designing buffering, so loading 2 megabytes is not going to be a problem. Streaming the 250 floating point numbers at every time step is not going to be a problem for bandwidth. So that's where this has led us.
Awesome. Yep. Nope. I think it's good. Makes sense. Scalable. So awesome. Was there anything else on the updates, Matteo? Did we get to the end of your list? Before I interrupted you, but I thought that was cool. So.
Yeah, no, it was. And since there's not too many people today, we can definitely get into more details. And where am I? Okay. Yeah, other people that are contributing to OpenWorm: Steven, Porg, Ali, and I haven't seen Ali in a bit. And so it's like Steven and Porg are, although not often working with the code itself, just providing either opening issues or providing general directions in terms of requirements that might be useful for working with a NeuML file, or like things that we might want to do with OpenWorm, things that we might want to do with WormSync. So it's like still contributors as far as I am concerned. And for the potential team members, Michael joined us for the first time this Monday, so he's interested in intersection with the movement validation, as we already described. So I'm eager to see him doing this, and I will try to help. And I already started with the loading of a recording that I was working on yesterday.
Yeah, and seeing that skeleton there too is pretty cool. So that's very exciting. Now, our skeletons have 49 segments over in movement validation, and it sounds like you have 22 points along that, or edges, if you will, along the skeleton there. So we'll have to merge that at some point, but that's a rather trivial issue.
It's a parameter, by the way. Martin told me that we can specify as many joints we want in the skeleton extraction algorithm. I just told him, look, take the minimum number that can give us a good animation of it, because the more we have, the more data we need to stream. But it's a parameter as far as I know.
Cool.
Makes a lot of sense to sync them, though, if it's not an overwhelming additional load. Actually, that's a really nice little sync point there. So. But yeah, I'm sure you guys can talk about it more. Okay.
And yeah, and then we had a new contributor, new recruit, Ruggero Carlos. That nice guy, seems to have a lot of experience with Java and Spring, and he has already a working development environment for Gepetto. So I think he's very close to be able to like either fix some bugs or take on some new development. And yes, anybody else that is interested in contributing to Gepetto, as always, welcome, because I'm really excited. There's like so much stuff happening that it's difficult not to get excited about it.
Very cool. All right. And so then let's go to Porg, last but not least, who's also been, I think, returned from a whole lot of traveling since we last met. So.
Yes, okay. So my main thing I've been working on in the last while, I'll just put in some bits in the agenda. The LIMS paper has finally been accepted. So that paper it's not in final proof, it's in final proofing stage, so I wouldn't recommend to download it just yet, but hopefully in a week or two it'll be ready to download and read through. So that describes current version of LIMS and how it's used to build NeuML version 2. And if anybody comes to the project as well wants to use either C302 or Neural Constructor or any of the other muscle model, it's hopefully an essential read. And when that does come out in the final version, we're going to have an updated NeuML 2 Beta 3 release, and then sync a number of the repositories, update some of the documentation, and just make sure that everything's in a stable form, and then continue with adding new features. So that will be over the next week or two, hopefully. One of the main improvements there in in latest release is that there's much better support for multi-compartmental export in Neuron. So if you have a NeurML2 model described with a multi-compartmental cell, it's got ion channels all over the morphology, like many of the pyramidal cell models that are out there and published, or even the Purkinje cell model. And eventually the detailed individual cell models in the C. elegans network, those can't be simulated with JLEMS itself, but they can be now loaded into JNeurML and exported to Neuron files, so Neuron hub file, mod files that are in distributed channels correctly. And we've tested that with a number of pyramidal cell models, and that's working nicely now. Will be tested even further as we go along, but it's one of the limitations had been that it was difficult to use multi-compartmental cells in version 2, but now that's hopefully resolved. The other thing I've been busy at is going to the INCF meeting. We had a useful workshop in Holland. Stephen was there also, and Rick Gerken and Shwejoy, and people from simulating Drosophila models, and there's a link on the agenda now to the all the slides from that meeting, and I believe the INCF has put up videos of our presentations as well, which I should put on that page, a link to each of the presentations during that session. So that's more for people to look at on YouTube after they've finished looking through this. And finally, the muscle model, yeah, Stephen was here in London briefly, and we had another update look at the Boylan-Cohen muscle cell model, the original code, and the original paper as well, and just saw some things which hadn't been updated, hadn't been incorporated into the NeurML2 model. I have a much better idea of what needs to be done. It's just another little bit of work that needs to be incorporated to make sure that that model runs or can be fully expressed in NeurML2, and once I'm done with releasing the beta 3 release, I'll get to work on that, and then hopefully we have a fairly complete model of that muscle cell. One thing I need to check is we did get some C++ code from Netterco and from that original model, and that the C++ code for actually optimizing the model, but that can run specific instances of the models with a specific set of parameters, and it's quite useful for one or two of the parameters we're missing from the paper, so it's useful to have that, and I just needed to ask her if we could put that on the GitHub repository also, because then we can add to it and make maybe a simple script for running a single simulation, so that we can compare the NeurML directly to a single run of the muscle model, and make sure that it's reproducing the model as closely as possible. So that's something I need to do. The other thing I've been doing over the last few weeks, but very intermittently, is looking at cybernetic. I've got that installed and running well on my laptop. I've been looking through my fellows Python files which came with that, and I want to actually look into extending or maybe getting some activity traces out of C302 and maybe trying to feed it into cybernetic, because there is maybe saving the traces in C302, feeding it into cybernetic, but there's a few steps to be done before that's going to be possible, but that's one of the things, hopefully before the meeting in November, that I want to get done, and try to close that gap and get cybernetic doing sensible, or at least some things controlled by a neural network. So.
Cool. All right, very good. Lots of things, and lots of sync points, I think, for different folks. By the way, I also want to, since you mentioned SciUnit, I do want to point to the mailing list topic that Rick Gerken has replied to now. I've been going back and forth a little bit, so although Rick does not join these meetings, let's just see if there are ways to incorporate some of that SciUnit stuff that he's been doing. I think that probably goes to the movement validation side as well, but do help me out here. And with any other things that I sort of have posted or forwarded to the OpenWorm discuss list, I know that there are folks that kind of are waiting for answers, and I tend to be the one mainly answering. So there was another person who posted on the list recently about about installing Cybernetic and their experiences with that and zooming and this kind of thing, and some stuff that I haven't experienced myself. So if there's anything on the list that you can help out with, please, I'd urge you, please comment on that stuff. It just takes one more email out of my box. I'm sure we're all filled with emails, but I seem to be particularly bad right now. So, all right, awesome. So, big picture, we are steadily progressing along with WormSim. Lots of excitement around Gepetto. Sounds like movement validation is also gaining steam with additional contributors, which is awesome. There's runnable examples. Kickstarter stuff has been trucking along quite nicely. LIMS paper out, which is great, and that whole side of things is also moving along quite well. We're presenting this at various forums, so that's great, and making some good progress. So, thanks everybody. I think we'll break it here a little bit early, give you back some time, and we will meet again in 2 weeks to see what's new since now. Great.
Thanks.
Cool.
Thank you.
Thanks.
Bye-bye.
See you soon.
All right.